So, the Earth is very old. It's estimated to be around 4.5 billion years old, but who figured that out? It all started in 1788 in Scotland with James Hutton, known as the father of modern geology. He figured out that rocks took millions of years to form. Another scientist at the time, Lord Kelvin, theorized that over time the Earth was slowly cooling down. Lastly, Arthur Holmes calculated the Earth's age based on the time it takes for uranium atoms to decay into lead atoms, and this is called radiometric dating. 4.5 billion years ago, molten Earth formed from countless meteor impacts. 100 million years later, as Earth was cooling, basalt was forming a crust and water began to form in small puddles, although most of the water was vapor in the atmosphere because Earth was so hot. This water came from asteroids, meteors, and comets that brought water and ice to Earth. About 4 billion years ago, Earth finally cooled enough for water vapor to condense. Clouds formed and it began to rain. This rain, however, lasted for millions of years and covered 90% of Earth, creating green, iron-rich oceans. 600 million years later, the basaltic crust under the oceans causes fissures to open up. Underwater volcanoes cause superheated water to mix with lava and form granite. This granite continued to form above the ocean crust because it is less dense than basalt, and the granite eventually rose above the ocean to form the continents. At 2.5 billion years ago, bacteria at the hydrothermal vents evolved to use sunlight and photosynthesize near the coasts of the continents. They still couldn't go on land, however, because the ultraviolet rays from the sun would kill them. Another kind of bacteria, photosynthetic bacterial algae called stromatolites, use sunlight to create oxygen. They also created waste product, however, and this was rocks. This bacteria created all the oxygen in the oceans and the atmosphere. They then created the ozone layer, which allowed life on land, oxidized the oceans making them blue, and are still alive today. 1 billion years later, stromatolites are still pumping oxygen into the oceans and the atmosphere, making the sky blue as the carbon dioxide was replaced with oxygen. Alfred Wegener created the continental drift hypothesis, which stated that the continents had once been together and have drifted apart over time. He thought this because fossil, rock, glacial, and mineral evidence match across oceans, where it seems like the continents would have fit together. However, most didn't believe him because he couldn't explain why the continents move. In 1950, Harry Hess explained plate tectonics using that US naval map. During World War II, sonar was used to track submarines and map the ocean floor. It revealed mid-ocean ridges and deep ocean trenches that showed that the ocean crust was spreading apart at the ridges and moving down into the mantle where it meets the continents. More evidence of this can be found in Iceland, where fissure eruptions show that the island is splitting apart, or the fact that Europe and North America are moving about 1 inch apart each year. 1 billion years ago, massive volcanism led to the continents being driven together into one large supercontinent called Rodinia. However, Rodinia was a barren, lifeless desert. It also blocked warm ocean water from reaching the poles, thus in turn making the poles freeze and eventually the whole planet for millions of years. 370 million years later, volcanic activity melted all the ice and split Rodinia apart. 100 million years after that, a period of rapid evolution called the Cambrian Explosion occurred. This was a period of rapid evolution where complex organisms evolved that would lead to fish and other types of vertebrates. Some of these vertebrates can be found today in the form of fossils at the Burgess Shale, a layer of sedimentary rock in the Canadian Rockies that used to be underwater. This is the oldest layer of rock to hold complex and diverse fossils. 400 million years ago, an ozone layer forms from the concentration of oxygen in the atmosphere produced by stromatolites. This ozone layer protects life on Earth from ultraviolet light. This allowed plants and animals to move outside of ocean waters and onto the continents in search of safety from predators in the oceans. 1 million years later, the amount of vegetation on the continent changed the environment completely. The world was a tropical swampland with large trees, lush swamps, and insects longer than 2 feet. The oxygen levels were 9% higher than they are today. This period is known as the Carboniferous Period. During this period, no insects or bacteria existed that could break down the material plants were using to make woody trunks called lignin. Because of this, all the trees that fell would pile up for around 100 million years until insects evolved to eat and digest lignin. This piled up wood eventually became coal. 250 million years ago, massive volcanism led to the extinction of around 95% of life on Earth. This period is known as the Permian Extinction. Because of all the volcanism, the ocean crust spread at a fast rate and pushed the continents together again to form another supercontinent called Pangaea. On Pangaea, dinosaurs evolved as huge lukewarm-blooded creatures that grew fast. Dinosaur fossils date back to 230 million years ago. Once again, massive volcanic activity led to the breaking of Pangaea. The dinosaurs survived this, but this is why their fossils can be found on the continents we know today. 65 million years ago, a meteorite struck Earth near the Yucatan Peninsula in the Gulf of Mexico. It was estimated that the meteorite was around 6 miles in diameter, based on the amount of iridium that was sprinkled over Earth's surface. Proof of this meteorite can be found in Mexico, where the meteor left a 100-mile-wide crater beneath the water. After the meteorite hit, 70% of life, as well as dinosaurs, went extinct. 50 million years ago, the dust and cold that occurred after the impact led to the survival of various species. Placental mammals now dominate the planet. 2 million years ago, a land bridge connected North and South America, formed by volcanic activity. This bridge blocked ocean currents and caused the Ice Age to begin. Glaciers and ice were coming from the North Pole and covered the continents. In East Africa, ancient humans evolved and spread out around the world. 10,000 years ago, a warm period began. This caused the glaciers to retreat towards the poles, allowing humans to settle in areas and form civilizations through farming. 10,000 years into the future, it is expected that another glacial period will occur. 250 million years into the future, the continents will be pushed around the Earth to form Pangaea Ultima, another supercontinent. 3 billion years into the future, the core of the Earth will have cooled to the point where the outer core will solidify. Because of this, the Earth will no longer have a magnetic field, and thus life on Earth will not be protected from harmful gamma rays and X-rays from the sun. The Earth will dry up and become lifeless like Mars. Many believe that this is what happened to Mars. Because Mars is smaller, its core did not make heat as long as Earth's core.